Welcome to my channel Ganit Matrix. Now, if you are preparing for engineering mathematics courses for universities like JNTU H, JNTU K, JNTU A, you are in the right place. Now, I specialize in breaking down the difficult exam problems into clear step-by-step solutions. So you can walk into your exams with total confidence. And this is double integral over general region, problem series, problem number 3. Make use of the concept of double integrals to find double integral y square dx dy, where R is the region bounded by the parabolas y square equal to 4x, x square equal to 4y. And remember that these two are parabolas. Y square equal to 4x is the parabola symmetric about x axis. So here this is y square equal to 4x. This is the general thing. Y square equal to 4x is the parabola symmetric about x axis. Similarly, x square equal to 4y is a parabola symmetric about y axis. Symmetric about y axis. This is x square equal to 4y. So this is the common region. This is the common region for two curves, two parabolas, y square equal to 4x and x square equal to 4y. Since our region is bounded by more than one curve, because we have two curves, so it must have intersection points. So how to find the intersection points? Since we have two curves, y square equal to 4x and x square equal to 4y, right? So from this expression, express one variable in terms of the another variable. Since here from first equation x equal to y square by 4, right? X equal to y square by 4, and therefore now substitute this x equal to y square by 4 in the second equation, x square equal to 4y. So this is x square means y square by 4 whole square equal to 4. So what we have done is we equate the two expressions so that the expression will becomes in terms of only one variable, and solve that equation that will give second one variable, and using this one variable values we will find the second variable values. So here we will find y and substitute these y values in these equations, we will get x values. So y square by 4 whole square equal to 4y, that means y power 4 by 16 equal to 4y. So y power 4 equal to 16 into 4, 64y. So this becomes y power 4 minus 64y equal to 0. Taking y common, y into y cube minus 64 equal to 0. Since the product becomes 0, product is 0 if any of the value is 0. So this is y equal to 0 or y cube equal to 64, that means y equal to 4. So if you give y equal to 0, then x equal to 0. So if you give y equal to 4 here, 16 by 4, so x equal to 4. So the intersection points are 0, 0, 4, 4. So here 0, 0, 4, 4. So next thing is to find the limits of the integration. So before going to the limits of the integration, we must we must identify which strip we have to take, the horizontal strip or vertical strip. See, we will evaluate this by using horizontal strip or vertical strip. But if you see this region, right? So I am taking the horizontal strip. That means first we are integrating with respect to x. That is, the order of integration is dx dy. See, you can evaluate this by using the order of integration dy dx also. Okay. So I am taking the order of integration first with respect to x. First we integrating with respect to x. Next with respect to y. So if the order of integration is dx dy, x limits must be functions of y and y limits must be constants. Okay. So how to find the x limits? Draw the horizontal strip through the region and identify where the strip enters the region and where the strip leaves the region. So since this horizontal strip enters at x equal to y square by 4 and leaves at x equal to 2 root y. Since x square equal to 4y, in the sense x equal to 2 root y. And what are the y limits? What are the y limits? If we going vertically, so y varies from 0 to 4. If you move vertically, y varies from 0 to 4 because the maximum point is 4. So y varies from 0 to 4, x varies from y square by 4 to 2 root y. Plug in these limits, so we will get y square by 4 to x varies from y square by 4 to 2 root y, and y varies from 0 to 4. Y square, because y square is our integrand, dx dy, because the order of integration is first with respect to x. So now how to integrate this? We integrate with respect to x, treating y as a constant. Okay, so we, since y is constant, we write the constant term as it is y square. Integral dx is x. Plug in the upper limit minus lower limit. So this is 2 root y square into 2 root y is the upper limit, minus lower limit is y square by 4. Now if you see that the total expression is converted into function of y only, right? So this is integral 0 to 4. Multiply that 2 into y square y power, since root y is y power 1 by 2 minus y power 4 by 4 dy, since y square into y square by 4, y power 4. So this becomes 2 into y power 2, y power, since bases are equal, add the powers, y power 2 plus 1 by 2, which is y power 5 by 2 minus y power 4 by 4 dy, which will be integrated with respect to y between the limits 0 to 4. Integration of same, we are using that formula, integral y power n dy is y power n plus 1 by n plus 1. So 2 into integration of y power 5 by 2, y power 7 by 2 by 7 by 2 minus integration of y power 4, y power 5 by 5 by 5, 5 into 4, 20. So this becomes, so 2 into 1 by 7 by 2, 2 by 7, so this is 4 by 7, y power 7 by 2 minus y power 5 by 20. Plug in the upper limit only, right? Plug in the upper limit. So this is 4 by 7, 4 power 7 by 2 minus 4 power 5 by 20. So this is 4 by 7, and 4 power 7 by 2 is nothing but 2 square whole power 7 by 2. So that means 2 power 7, which is 2 power 7 is 128 minus 4 power 5 is 1024 by 20. So this is 4 into 128, 512 by 7 minus 256 by 5. Now take the LCM 35 and 7 5 just 5 into 512 minus 5 7 just 7 into 256, which is 1792. So finally we'll get 768 by 35. So this is our final answer. Thank you.